GitHub's 24-hour database reconciliation, a DevOps Postmortem. It's 22:52 UTC on October 21, 2018. For most people, it's just another night of routine maintenance. But for the engineers at GitHub, it's about to become a marathon of architectural triage. A mere 43 seconds, a blink of an eye in the world of networking, is all it takes for a minor partition between East Coast data centers to spiral into a nightmare. Suddenly, the MySQL clusters aren't just lagging, they're drifting apart. The automated failover systems did exactly what they were programmed to do, but they did it in a way that fractured the topology of the entire database. By the time the dust settled on that initial blip, the system was in an inconsistent state, and the stakes were massive. They weren't just fighting a bug, they were fighting a ghost in the machine that would haunt their infrastructure for the next 24 hours. Imagine a world where your code lives on GitHub, the literal backbone of the modern developer's workflow. If that system hiccups, the entire ecosystem feels the tremor. On October 21, 2018, GitHub hit a wall that serves as a masterclass in why integrity is often a heavier word than uptime. It started with a mere 43-second network partition between their US East Coast data centers during routine maintenance. That tiny window of silence was enough to trigger an automated failover, causing their MySQL clusters to diverge across regions. Instead of just a quick blip, they were suddenly staring at a split-brain scenario where writes were landing in two different places simultaneously. They had to make the hard call, shut down parts of the service, and spend over 24 hours manually reconciling data. It was a grueling marathon to ensure that not a single commit or piece of metadata vanished into the void. It was October 21, 2018, and for GitHub, it started as just another routine maintenance window. On the surface, everything looked standard, the systems were humming, and the infrastructure felt stable. Then, at 22:52 UTC, a tiny fracture appeared in the foundation. A mere 43-second network partition hit the East Coast data centers. In the world of high-availability systems, 43 seconds is usually just a blink, a minor hiccup that automated failovers are designed to swallow without a peep. But this wasn't just a blip, it was a catalyst. The momentary drop in connectivity triggered an automated failover process that didn't realize the ground was shifting beneath it. Instead of a seamless transition, the system began splitting writes across East Coast and West Coast clusters. What started as a routine maintenance task was about to transform into a grueling, 24-hour manual marathon to stitch the data back together. It started at 22:52 UTC on October 21, 2018. At first glance, it looked like a routine blip, a mere 43-second network partition between the East Coast data centers. In most scenarios, 40 seconds is just a hiccup you ignore and move on from. But this wasn't a standard glitch. It was a ghost in the machine that triggered an automated failover. As the engineers began to peer at the monitors, they realized the MySQL clusters had begun to diverge. The system thought it was making a smart move by rerouting traffic, but instead, it was splitting writes across different regions. Within those first few minutes, the reality set in. The topology was becoming inconsistent and fundamentally unsafe. What started as a tiny network flutter had just transformed into a massive data integrity nightmare that would keep the team awake for the next 24 hours. It started with a flicker, a mere 43 seconds of lost connectivity between the East Coast data centers during routine maintenance at 22:52 UTC. In a perfect world, it would have been a blip. In the real world, it was the spark that lit the fuse. The automated failover kicked in, but because the network and the logic were out of sync, it began splitting writes across both East Coast and West Coast clusters. Suddenly, the topology wasn't just messy, it was inconsistent. Data started landing in different regions, creating a fractured reality where the system didn't know which version of truth to believe. What should have been a minor hiccup spiraled into a massive reconciliation nightmare. Because they chose data integrity over immediate uptime, the team was forced into a grueling manual process to stitch the broken pieces back together, leaving the service in a degraded state for over 24 hours. So, what actually broke the gears? It started with a tiny tremor, a mere 43-second network partition during routine maintenance at 22:52 UTC. In most systems, 40 seconds is a blink of an eye, something you'd usually ignore or let a heartbeat check smooth over. But here, that blip triggered an automated failover that played by its own rules. Because the East Coast and West Coast clusters couldn't see each other for those few seconds, the system assumed a catastrophic failure and split the brains of the MySQL cluster. Suddenly, writes were landing in two different places simultaneously. The topology became inconsistent. You couldn't just flip a switch to merge them back together because the data was physically diverging across regions. To keep things simple, the logic followed the integrity first rule: if the state is uncertain, stop everything. That's how a 43-second glitch turned into a grueling 24-hour manual reconciliation marathon. It started with a mere 43 seconds of lost connectivity between the East Coast data centers during routine maintenance at 22:52 UTC. That's at less than a minute of network silence. But in the world of distributed systems, 43 seconds is an eternity if your automation isn't perfectly dialed in. The partition triggered a failover that split writes across both East and West Coast clusters, creating a fractured topology that was fundamentally unsafe to just fix. Because they chose data integrity over immediate uptime, the blast radius expanded into a grueling 24-hour ordeal of manual reconciliation. For over a day, GitHub had to operate in a degraded state, manually validating every discrepancy while webhooks and pages were paused. It wasn't just a brief flicker. It was a full day of high-stakes surgery on their data tier to ensure that not a single write was lost in the cracks of the split. At 22:52 UTC on October 21, the first domino fell: a mere 43-second network partition between GitHub's East Coast data centers. It sounds like a blink of an eye, but in high-stakes infrastructure, 40 seconds is an eternity for an automated system to make a wrong move. The failover logic kicked in, and suddenly writes were splintering across both East and West Coast clusters, creating a fractured topology that the system couldn't stitch back together on its own. The engineers weren't just fighting a bug. They were staring at a split-brain nightmare where data integrity was hanging by a thread. For the next 24 hours, the team lived in a state of high-pressure triage. They had to make the hard call: sacrifice uptime for correctness. They paused webhooks and pages, grinding through the manual labor of reconciling every inconsistent write to ensure not a single byte was lost before finally restoring service. Fixing this wasn't a simple flip of a switch. It was a grueling exercise in surgical precision. Because the data had already split across regions, GitHub couldn't just turn on the primary site without risking massive corruption. They had to make the hard call: prioritize integrity over availability. The team moved into manual mode, pausing webhooks and pages to isolate the blast radius, while they painstakingly reconciled every write that had landed in different clusters during those chaotic hours. It took more than 24 hours of grinding through the logs to ensure the topology was safe before full service could be restored. To make sure this ghost wouldn't haunt them again, GitHub overhauled their data tier and invested heavily in hardening their failover automation. They learned the hard way that a 43-second blip can cause a day of agony if your automated systems aren't built to handle a split brain. Look, the hardest truth we had to swallow here is that in the hierarchy of pain, data integrity sits at the top. When that 43-second network partition hit at 22:52 UTC, it wasn't just a blip. It was a fork in the road where fast became the enemy of correct. The automated failover did exactly what it was programmed to do. It kept things moving, but it moved them into an inconsistent state across the East and West Coast clusters. We learned that while high availability is the goal, you can't automate your way out of a split-brain scenario without extreme caution. If a brief flicker causes a massive reconciliation headache, your failover logic is too aggressive. This wasn't just about fixing a bug. It was about recognizing that sometimes you have to pull the plug and choose correctness over uptime, even if it means spending 24 hours manually stitching the reality back together. That's how GitHub turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.